Okay, first of all, thank you for having us. I'd also like to thank my collaborator who is also online, Nathan, for her assistance. And so I'll get right into it. Our paper is quite different in that it has been running through all the talks of yesterday and from what I've seen today. So our paper is about bounded rationality and artificial intelligence and the prospect of artificial intelligibility. Just to help everyone who is not familiar, the idea of bounded rationality is that there is limited time, limited information, and limited processing capacity in order to make decisions and to think rationally. The irony of giving a 5-minute talk. So, in order to keep this straight to the point with the obviousness of this bounded rationality, I will just get to the heart of our paper. The core question about human-machine collaboration that we are concerned with is this idea of artificial intelligibility. So we are all familiar with the basic idea of artificial intelligence. But the issue, as everyone has been describing in this conference so far, is that artificial intelligence does not necessarily rely or produce artificial intelligibility. Sorry, I'm trying to zoom in here. Here we go. So, as you can see, when we look at design, right, we see a lot of very, very familiar elements, right, that fall under procedural rationality, the kind of design that occurs when you're programming. And you see a lot of familiar elements when you're trying to build a neural network, as in probabilistic rationality. But what humans actually do in design and everyday life is operate with situational rationality, right? So whenever we are creating a design, there is something that we are embedded within, and that is discourse. So what I wanted to try and bring our attention to in the short time we have here is for us to really, really think carefully about the difference between these two priorities. And so the one thing I just want to quickly draw our attention to, which I think is the most important element here, is the issue of an adaptation to ambiguity, right? So the very nature and character of design is that it tries to reduce ambiguity. And one of the most important elements of social life from a sociological perspective is actually the maintenance of ambiguity. So it's in that sort of respect that we have a really, really difficult problem on our hands if we are going to try and arrive at a point where algorithms can actually understand in a fundamentally legitimate way what is going on, if it is not merely a matter of prediction or procedure, right? So to bring down our focus down here just a little bit, right? So in terms of, we have human problem solving and machines, right? So we got bounded rationality here, coherent probability here, and human intelligence here. But when you organize the information, you see that humans are really good at getting that intelligibility. But machines currently lack it. To really conclude what we are talking about here the idea of chess serves as a really quick example, right? So everyone knows that all these algorithms have been beating humans at chess, but arguably the difference is that they're not really playing chess, they're computing. And if we take humans to be the sort of being that actually has to deal with opponents and the kind of ambiguity that you can't get rid of in a situation, then that is the sort of ambiguity that an algorithm certainly does not have. So if we want to arrive at a sense that we can actually trust algorithms in a way that humans trust other humans, right? Then, it's not enough to merely talk about imitation. It's a matter of intelligibility. Thank you.